So what I'm going to do is I'm going to start from scratch. From original functions, so what I'm going to do is I'm going to start from scratch.
Oops.
From original functions. All right, there you go. From original function here, what we're going to do is figure out what the x-intercept and y-intercept always. If you figure out x-intercept and y-intercept, that's the way to do it. So how do I find x-intercept? X-intercept basically just factor as much as you can. So I'm going to say f of x equal to x to 3 times x minus 4. And then x is equal to 0, x equal to 4. So here you're going to have a 0, 0.
It's not changing, Mr. Ye. The screen's frozen.
Screen's frozen. Okay, maybe I should stop live streaming. Wait, you're talking about my screen, my iPad screen is frozen?
Yeah, it still just says x to the power of 4 minus 4x to the power of 3. It didn't change when you wrote on it.
Let me reshare again. Hold on a second. Let me reshare again. I think it's too much bandwidth to do that, to do live stream and Zoom call. Let me see it. Let me try it again though. We'll see what happened. How about now?
Yeah, it's good. We can see now.
Okay, so this is gonna be 0, 0 and 4, 0. So that's gonna be a y-intercept. X-intercept, sorry. So x-intercept and y-intercept. In the original function, you can always find x-intercept, y-intercept. Sorry, this is both x-intercept. Well, this one's x-intercept and y-intercept at the same time because of origin. Always graph the x-intercept and y-intercepts. This case, the y-intercept and x-intercept are the same thing, but usually you got to find y-intercept as well. In order to find y-intercept, just plug in x is equal to 0. So I'm going to write down x-intercept is plug in y is equal to 0. Y-intercept is plug in x equal to 0. And you don't understand how this tool is going to help you on SAT. It helps you so much if you can figure out what x-intercept and y-intercept. A lot of questions on SAT, it can be very, very simply just take care of that. You're going to get an answer. And that's original function. Now, what we learn in calculus is we learn a little bit more. We learn how to take derivative. We learn how to do number line tests, and we're going to incorporate everything in there. Okay, so what happened is we're going to show you. We're going to go ahead and keep on taking derivative and do number line tests. If I do that out of original function, I'm going to get 4x to the third minus 12x squared. And please do ask questions, because if you don't understand how to do something, just ask. And then I'm going to factor out as much as I can. So before x squared, and that's going to be x minus 3. And I'm going to find critical number. How do I find the critical number? Just set it equal to 0. And x equal to 0, x minus 3 equal to 0, x equal to 3. So there are two critical number. But after this critical number, I'm going to go a number line test. I'm going to go with 0, and I'm going to go with 3. So I'm going to get 4x squared, x minus 3. Now, 4x squared is always going to give you positive, regardless of which region is. And for here, I'm going to give you negative, negative, positive. So that's going to be, this one's f prime of x. So that's going to tell me that's going to be negative, negative, positive, which is decreasing, decreasing, increasing. Now, let me ask you, where is relative? Is any maximum and minimum here? And where they are?
Minimum 3.
Minimums at where?
Minimum at 3.
3, yeah. So 3 is your minimum, is relative minimum. And that's very important information in the graph. But except that you just only have X value, you have to go back to figure out Y value is. So in order to do that, I'm going to go back to figure out. So let's just say f of 3. And that's equal to 3 to the 4th power minus 4 times 3 to the 3rd power. And that's equal to 81 minus 4 times 27. I think is 81 minus 108. And that's equal to negative 27, which is at 3 and negative 27 is going to be your relative minimum. So not only you had to find the X value, you had to go in and find a Y value. Okay, you had to go and find Y value. If you can find a Y value, then you can figure out how everything works. Any questions here? Good. You can like give me like a thumbs up or something. That way I know like everybody's doing okay. There's a button shows thumbs up, or it can show me thumbs up. Okay. All right, cool. Now, after that, I find the relative minimum. I am gonna go in to figure out what is, yes, Braden. Yeah,
Sorry, it was an accident. It was an accident.
Oh, it was an accident. Okay, so now I'm gonna go in to do the second derivative. Second derivative is gonna be is equal to 12x squared minus 24x. And I can figure out by finding the possible inflection point. Again, when second derivative equal to 0 does not mean it's inflection point, it just means possible. So I have 12x equal to 0, x minus 2 equal to 0, x is equal to 2. So again, I'm going to go 2 here. And I'm going to 12x and x minus 2. This one is going to be, oh, sorry, not 2. I had to do 2 and 0. My bad. 0 and 2. And this one's negative, positive, positive. And x minus 2 is going to give you negative, negative, positive, positive, negative, positive. This is going to give you concave up, concave down, and concave up. So how many inflection points are they?
2.
0 and 2. Good. So this is 0 and 2, but you have to go back to figure out the coordinates. So I'm going to go back to figure out the coordinate. F of 0 is going to be 0. So 0, 0 is going to be an inflection point. We're going to call it IP. And 2, I'm plug in. So F of 2. And if I do a calculation wrong, just let me know. So 2 to the 4th minus 4 times 2 to the 3rd, that's equal to 16 minus 32, I believe. That's equal to negative 16. So it'll be 2 and negative 16. So you just have all the information about this graph. And you can come up this graph very, very easily. You just have to plug in a point. Now, you have to do it a systematic way. So what I tell students, usually you do it with systematic way. You can actually go in and you can figure out what is going on. Who's admin? Is that Zach? Why are you here anyway? You can calc too. Go away. Your class at 1 o'clock. I'm like, who the heck is that?
I got nothing else to do.
Oh, okay. You can play Roblox. All right. Anyway, so what I'm gonna do is I'm gonna sketch this graph. And I'm gonna go here. Now, for me, I'm gonna go into first information. The first piece of information I have is the x-intercepts and the y-intercepts. So 0, 0, and 4, 0. So I'm going to just do 0, 0, and 1, 2, 3, 4. So I'm gonna use 1, 2, 3, 4, 0. So I'm gonna plug in those points. Always do the y-intercept and x-intercept first. Are we okay so far? Now I'm gonna go to relative min. Relative min is gonna be 3 and -17. So 3 and -17. Now the problem is that I have here is my increment. In order to go down 27, I need a bit graph. So I'm gonna change the scale here. I'm gonna change each one is 3. Maybe that'll help me. So this one is gonna give you hold on a second, 27. I can do each one is
It's 8.
I'll do each one's 3. Oh, each 2 is 3. Well, this one's 3. So this is 9. This is 18, and this is 27. I just changed the scale a little bit. So 3 and -27. So what happened is minimum, I'm gonna do a smiley face. I think somebody mentioned that in Calc BC. Either smile face or sad face. Because the minimum is gonna be a smile face, if is maximum is gonna be a sad face. Are we okay here? Okay. At 2, so we have minimum. So we can go back and finish check all the information. This information already fulfill. This information already fulfill. And 0, 0, and 2 and -16. So 2 and -16 is going to be somewhere around here. So 0, 0 is going to be, we're going to label this point as a cross. A cross means IP. So we can write IP, just kind of tell you that there was an inflection point change. And there was 2, 18. So 2 and -16. 2 and -16 is roughly right here. So it's roughly right here. So if you don't want to know, you want to know like coordinate, it's probably 2 and -16. Okay, so when you get to this point, you do have all the information now. All the information you have, the only thing is we did not apply is the number lines, like increasing or decreasing or concave up, concave down. Okay, that's fine. Deborah, can you hear me? Deborah, you can hear me, right? Oh no. Okay.
I think it just froze.
So now, now I'm going to go in to follow the decreasing, decreasing, and increasing. So I'm going to decreasing all the way down to 3.
Did he leave?
That does seem to be what happened.
I think there was a Wi-Fi thing.
Probably. Streaming.
Am I back? Sorry, how long I was out?
A good 2 minutes, like a good minute.
Okay. So let me go back and let me share my screen. I know that the thing's not really stable too. So. Okay,
Oh, you did all of that? Whoa, okay.
okay, so let me redo it
It
again.
froze when you only had the 2 and -16.
Yeah, it froze when you had like nothing, like you just did the points and the smiley face.
Okay, that's fine. I will do that again. So do I have the y-intercept before?
Yeah, you
X-intercept?
you did. You were
You had all the points. You
Yeah,
had
you
all
had
the points. You
Yeah,
just
you
hadn't done the
said we're
graph
gonna
yet.
decrease to 3, and then that was when you cut off.
Okay. So I hear it's gonna have a smile face. Is that okay? Because of the
Yeah.
minimum. And at 2 and -16 is gonna have a cross. A cross means the inflection point, and cross means inflection point. Is that okay? So far, it's okay. Can you guys hear me?
Yes.
Okay.
Yeah.
Yes, we could hear you.
And then I'm gonna decrease. I draw the dotted line just because I'm not for sure what the graph is going to be yet. Okay, this dotted line just give me a decreasing, decreasing, increasing after 3. Because that's what it says, decreasing, decreasing, increasing. So we finished this check mark right here. I use a green dot. Now we're gonna go with the black. The black is gonna go with here. And then I'm gonna start with concave up. After I go through cross, I need to make sure I change in concavity. So that's why I do cross. The cross remind me to change concavity. So I'm gonna start with up, right? And if I start with up here, then it's gonna be like something like this. Does that make sense? Because it's concave up and decreasing. I follow the green line, but I have a concavity established. After I go through the red cross, I know concavity is going to change. So the graph's going to be like something like this. After the red. And then I can
You're losing
erase.
connection again.
Yeah, can you guys hear him?
Can you hear me? Oh no.
Yeah, we can hear you, but you keep like going back and forth between on and off and then skipping ahead and then going back.
Okay, so let me stop the live stream. Maybe that'll help.